power, so we are good, hopefully. Yeah. Okay, hello everyone. Thank you so much for joining for this session. I'm going to discuss about the emerging cybersphere of smart mobility, and I'm Ikjot. So this is a little introduction about me. I'm assistant professor at University of Windsor in School of Computer Science, and I'm also founder of Eminent Cybersecurity in the student chapter. Currently, I'm also serving as academic director for the Security Research Group and academic chair for Women in Cybersecurity Ontario affiliate. I think VICES is similar to what CSNP is. So feel free to ask me about this as well, or reach out to me to know more about VICES. And I'm also stream owner of IoT and Edge Security for Aggregate Intellect. So the outline of this session will be, we'll just quickly go through the introduction, and then we'll dive into what's new in this cybersphere and what are the opportunities and how we can get engaged in it. So we'll start with the auto security introduction. So first of all, the first question is, why do we even need smart mobility? So the first answer, or the quick answer to that, is we have seen a lot of collisions and many of the casualties in the road accidents in recent years, and it's growing more and more because we are having growing number of vehicles on the road. Plus, that also affects the congestion, and it causes the traffic jams, especially on the highways and the city centers. So we want to manage that congestion and the traffic flow in efficient manner. But as of now, we are not able to do it because a lot of infrastructure is not built solely for that reason. So these are some of the stats. This is Canadian stats, not US stats. I didn't get that. So the first idea to introduce connectivity among all the vehicles is to prevent those road collisions, as well as to somehow make more meaningful ways to find that there are no congestion, right? So we want to reduce it and make it more in a way that whenever a vehicle goes on the road, it has a flow. And like we today see Google Maps, where there are 3 different ways: green, orange, and red, to indicate the traffic congestion. But rather than that, it would be efficient to see, without any stop, how you can navigate through a road network. So that's why we need connectivity, and I'll discuss further how this is. I'm going to focus more on the safety related discussion and why it's important for the safety purposes, because that's the sole reason intelligent transportation systems across all countries have started focusing on bringing V2X connectivity in all the vehicles. So what's going to happen? So this picture captures the essence of connectivity. So think about how devices are connected to Wi-Fi and the cellular base stations. So that model is a little bit different than what we are used to, is different than what we are seeing here with the vehicles. So these vehicles, as nodes of the network, they are interrelated, interconnected, and it's a dot network. It forms on the basis wherever it goes, and it's highly dynamic in its topology, and it moves really fast. So you can imagine how it would be different than current mobile network that we have, because it depends mainly on the base stations. But this network is not only going to be talking to the base stations, which are infrastructure units, but also going to interact with each other among its nearby vehicles. So why do we need that? Because we want to, so today also we use ADAS systems, which provides the situational awareness, just immediate situation awareness, where the vehicle can see in its line of sight. But what happens in its vicinity of 100 to 200 to 300 meters? If the vehicle would have that awareness, it would be able to make better decisions and warnings and alerts for the safety related applications. So these are some of the connected vehicle applications. There are so many more, but this is just for illustration how we can have certain warnings, and which can aid the driving or the driver to make, like we today have the ADAS systems, we can get the blind spot and some other warnings and alerts. but this will give advanced vehicle safety awareness and the messages, which will be cooperative collision warning, lane change warning, intersection warning. So these are the main use cases which are being tested as of now. And in Europe, there is an approaching emergency vehicle or preemption warning alert as well, where all the vehicles on the road would be given an alert when there is an emergency vehicle in its vicinity or coming by nearby. Next is work zone warning and rollover warning. So these are some of the examples. So how about to understand further the location awareness for safety warnings? The question would be, how would it enable it, and why would it need that information? So if you see in this diagram, we have the two vehicles which have three vehicles in the middle of them. So this vehicle, which is on the rear, it needs to get information from the vehicle in front, which is three vehicle having in the middle of it. Let's say the first vehicle have a hard brake, or sense some problem on, let's say in Canada, we possibly have, in Chicago as well, we have black ice. So that's a weather related issue. But the vehicle which is in the front would sense it first at the first hand, and then it would, if it sends that information to all the vehicles rear to it, then those vehicles can adjust and make changes, and drivers will be alert for that, and this would overall would prevent the collisions or the casualties that can happen because of these kind of situations. So that's why this location awareness is within a network of the vehicles on the road, and this network can be the distance is 300 meters, and this is just for the vehicle-to-vehicle communication. And what messages these vehicles send, these are called basic safety messages for the safety related applications. And it has actually two parts. The first part, messages sent 10 times per second, and it includes the location, speed, direction, and traffic. So that's a lot of information to send. And just to add on to that, a privacy issue, that it's sent in a clear text. That means it's not encrypted because of the low latency requirements for processing of safety related applications. So the another thing is to understand why connected cars. So most of the times I get this question: is connected car same as autonomous, or what's the difference? So today we are on the right side. You can see the driver is in charge of this vehicle and is responsible for making that decision based on the warnings and alerts it gets. So on the left side, you can see the driver is not in charge. You can actually just navigate, just actually sit down as a passenger and occupant of this vehicle, and this vehicle will make all the decisions by itself. The only difference is, the similarity is both vehicles will get that information from the network of the vehicles, but today that where we are in sense of autonomy of vehicles, we are at with Tesla, we are at 2.5 level. When we are going to move forward, let's say it's level 4, then we are going to see more and more of the picture on the left side. But connected vehicles are going to bridge that. So it's like another step closer to autonomous vehicle. It just makes those vehicles more intelligent. Next is this ecosystem. The whole ecosystem of this vehicular network, it would not actually work if all the vehicles are only the entity or element in this ecosystem. So it needs to work based on the infrastructure. So we need to lay down that, and then based on that, it will be able to communicate with different radios. So in the future, we are going to see more and more different variety of radios in the car. Today we have a set of radios. So this technology, that there's a whole debate going on that technology for DSRC and V2X, CV2X. So if we are going to have that, so the smart intersections or the traffic lights will be intelligent and will be making decisions as well. There will be a satellite communication, mobile communication. There will be security systems, because this is going to be Internet of Vehicles. So since it's Internet of Vehicles, we definitely need a security layer. So that's very important. So all the vehicles, all the entities will have their own digital certificates and signatures. And based on that, it will send information. And that's what we are trying to protect on the V2X security. So connected vehicles, V2X, which is vehicle to everything, vehicle ad hoc networks, all these terms are similar and synonymous. And so on the right side, you can see a picture which indicates what kind of or types of communication models there are, or what kind of networks we can form under V2X umbrella. So that's vehicle to infrastructure, vehicle to vehicle, vehicle to device, vehicle to pedestrian, and there is also vehicle to cloud. So whatever you can see as, so imagine a vehicle as an endpoint, and it's going to communicate to everything in its ecosystem. So when you're thinking to protecting or securing, you are thinking about all those different layers and communication paths to protect and secure. So here's, this is the demonstration how this actually works. So each and every vehicle is equipped with onboard unit, which has a DSRC technology or protocol in it, which is dedicated short range communication that enables all the vehicles to communicate with each other for 300 meters range. And it allows, it's like a Wi-Fi, it's a variant of a Wi-Fi. It's IEEE 802.11p. And it also has a security standard that works on IEEE 1609.2. So all the vehicles will communicate with each other, forming V2V, and also communicate with roadside units, all the infrastructure units, forming vehicle to infrastructure communication network. On the back end, it has the location authorities and certificate authorities. And that's the V2N communication. So there is a inherent privacy, location privacy risk in the system. As I earlier mentioned, the basic safety message, the first part of this includes the location timestamp and a vehicle ID. So this vehicle ID shouldn't be giving away the information of the driver, because it can be, that particular person can be victimized by identity theft, or some of the other problems can occur. So this particular message would have an ID that should identify the vehicle itself. So how we can secure that? So in literature or in according to today's standards that's still being evolved. They have the anonymous authentication as one of the ways we can solve this problem, by pseudonymization and giving a temporary ID, which would not be able, which over time it's not likely that the temporary ID would relate the location of the person. But what happens that it needs to change over time. So this whole concept was the basis of my thesis when I did my doctoral dissertation. It was based on the privacy assessment and finding the ways the privacy can be breached, or how far an adversary can go, and in different models in the different scenarios. So if you have any question, you can ask me regarding that as well. So next is defense and depth building blocks. Since there is a whole layer of auto software security, and whoever is developer, so there is a problem with the awareness that developers, software developers, need to know that they definitely play a major role in auto security, because they are the ones who are going to build those systems. And if there is not security by design or privacy by design right from the beginning in the design as a design principles, then that's a problem in auto security overall, because we are going to send that vehicles. Think about the lifetime of the vehicle. It's at least 10 years. So whatever we are putting today in that particular software, that's most of the time it's the embedded system we deal with in the automotive sector. So whatever we put there, if we are not able to change it, definitely there's a lot of things that we can remotely update and send over the air updates. But what happens if there is a problem in the design itself for an embedded system? So that's what we want to prevent as of now. So some of the areas where we need defense to protect the auto sector is software and services like anti-malware, network enforcement, biometrics, cryptography services, anomaly detection, over-the-air updates. I can give you one of the examples. One of the auto manufacturers, they recently, I cannot name it, the auto manufacturer, but they definitely had this issue that they didn't discuss with the engineers when they were putting the key fob encryption. So that was a very poor encryption that they picked. So that's one of the problems that is in auto sector, that um, there's a lack of communication and transparency, and there's a lack of communication within the different departments. So so that's one of the emergence of this technology with the automotive. It's going to be a complex amalgam, and people need to understand, even when you're a developer, you're working for an auto EM, it's important to note and communicate that information if there is a potential threat or risk within the underlying components. So this whole cybersphere, which is formed with the mobility, it brings new challenges in it. So earlier we had vehicles, and vehicles were driven by drivers in the physical world, and that's the only thing we had. At max, in the advanced systems, we had ADAS systems to provide and assist the driver with some advanced warnings. But if we introduce a whole new layer of internet to these vehicles, what would happen? Now every vehicle will be connected to each other. Now it will form a new world, which will be autonomous and connected, a world. Autonomous in coming future, not today, but definitely we are going to see that more and more, hopefully with some OEMs like Tesla. So this forms a new cyberspace. So now we have the three different entities. We have a vehicle, we have a driver, and passengers definitely, and Internet of Vehicle, which was not there. So what happens with this? Since imagine about just the internet, we are connected with the devices. Since all the devices are connected, some part of the words is always on, like not on, but some devices are always on. And that's going to be the similar case in the Internet of Vehicles. It's so widespread that once it's on, all the vehicles on the road, wherever it's in the world, they're going to be on the internet. So it's like, it's a subset. If you are already expert in IoT, you can imagine that this is a subset of IoT. It's just the internet of vehicles. So some of the challenges are that it's always connected vehicle, always, all the time connected, and it's very large scale network, irrespective of where you are, because vehicles don't have the boundaries. It doesn't have the local boundaries. You actually move from one border to another border. So that's also something which is new in it. So by design, it collects private data. As I earlier mentioned, it's a temporary ID related to or given to one of the vehicles, all the vehicles actually. Each one has their own temporary identifier called pseudonyms, and they are changed frequently. But if you over time, as an adversary, sniff that information and collect it, with just simple analysis, you'll be able to get the information or tracking information for that particular vehicle, or have the mobility traces as well, or the patterns. Next problem is the immediate effect on human life. I started seeing the security in auto sector as a safety issue. So since it's a direct impact on the human lives, and we have never seen such a network which was having direct impact on human lives. So this is something new, and it's really challenging, and that makes security specifically a major reason because of which the customers would be feeling that they are not putting their whole trust in this. So rolling out V2X is going to be a challenge, but how we can do it, providing more and more robust and reliable solutions. Auto security challenges, these are some of the challenges. So software security in connected vehicles is lagging. As I earlier mentioned, the software is not up to the mark for or where it should be as of now for the growth of V2X. It's not there yet, and there's a it's a continuous growth and evolution. Most of the time, the automakers see security as one checkbox mentality, and it's not that. It's always growing and it's always evolving. And we would see some of the attacks and the way the attacks are launched. They were not there previously in previous any of the cases. The another problem is security is seen towards the end of the life cycle of the product, which shouldn't be the case. It should be on the left side, more on the design side. So another thing that is of a concern is standards are still in development, and different regions or different countries are working at a different pace. So for example, Japan is way ahead, and then next is Singapore, and then Europe, and then States. So I remember that I started in 2016 for V2X SCMS work. At that time, States has a proof of concept for security credential management system. After that, it slowed down. So we'll see, hopefully now that it will accelerate again. So the threat vectors in the supply chain. So this is a very big problem too, because different components come from different manufacturers, tier 1, tier 2, and they need to understand that they comply with the security regulations and standards, and that would ensure overall that whatever is put on one vehicle, whatever is integrated, everything is secure. Next is the software security in our industry. As I said earlier, security is safety in this sector, and security controls like IDS and firewalls are not sufficient, because most of the time we see the gateway to the vehicle, which is most of the time, as of today, we have telematics units, which we can at least imagine that that's the gateway from where, or the radio, wherever we can actually insert the malicious code or can get into the network. If we just simply put IDS and firewalls there, it would be sufficient. No, it wouldn't be. As it grows, and it's going to get more and more sophisticated with time. That's why it's important to have the supply chain in mind as well, because when you're placing one little component which is compromised, that itself is an issue. It's not coming from connectivity itself. Another problem is continuous monitoring, which is required in this whole network of vehicles. The current state is the security testing is in the product release process, which is late. We need to get it into the design or development phase at least. So the vision of the industry is that cybersecurity is just one of the standard processes. Just like safety testing for a vehicle, it took so long, like 70 years, to get this safety standards, safety assurance standards, so that when we sit down today in a car, we are just assured that everything is checked already, and we are just comfortable sitting in it. Similarly, this is going to happen as a standard process. It's evolving. Today, different OEMs have their own processes to evaluate the security. But over time, it will be just one comprehensive standard process which everybody would be following. Some of the overall challenges with the industry itself is skills shortage. So there are a few things to discuss here. What happens, it's a skill shortage not because we don't have the skills, but it's more about we do have people with the skills, but they don't know how they can apply here in this area. So for example, I came into this area with my thesis when I was I was in computer science and engineering, learning network and security. I was really passionate about learning something that's relevant and tangible, and which we see day to day. That was internet. And then when you think about Internet of Vehicles, it's very relevant. Someday we'll be using it. So that's how I get into it. But when I'm asked most of the times, who else can do this out of security? So the answer to that is we need electrical engineers, we need civil engineers, mechanical engineers, automotive and industrial engineers. We need business and law school people, because they understand some of the things that we don't understand, And there are so many blind spots for each other. And also definitely research from academia needs to bridge with the industry as well for these topics, because it has real implications, and you just cannot create something theoretical and which is not applicable to the industry. So there is skill shortage in terms that there is no course or program. It's rare to find the program. But if you're in a master's enrolled, you definitely can always start a thesis on it, and you can work on it. It's a very niche as of now, but it's going to be prevalent in coming future. There's a scarcity of resources just on auto security because there are different um, sectors within it. As its whole, as a vertical, further it has many verticals in it. For example, in vehicle security, V2X security, supply chain, OT, and IT security within this system. Next is the checkbox mentality. In auto sector, we have seen that it's very slow to catch up for that sector. And also, if the manager for this whole program, if he or she is just imagining that it's a one-time security certification that I have to do, it's not going to be like that. It is always evolving and always changing, especially something which is completely new as of now. So that needs a completely new set of, I think it's also a mindset that we need to change, and the training and education. I'll discuss about this towards the end, that how you can get involved more and network with these people who are already engaged in it. And training is, as of now, there are not many resources, but for education, I will say there are plenty of resources to self-educate on this topic. So this is an open question you can answer maybe in chat or maybe just by yourselves, that if do you like cars? Does cyberspace interest you? If you answer both of these as yes, then you are definitely somebody who can contribute to this area. So how can you get involved and make a difference in this emerging technology? So the opportunities for individuals, so they can be automotive engineers. If you or your friends are automotive engineers, so they need to learn the secure coding methods. So here I'm actually listing what are the opportunities. So you already know, since you're an automotive engineer, what to do with the automotive side, but where your blind spot is, it's the secure coding methods, because you want to protect it and have a secure way when you're writing something new. Next is cyber security professionals who actually help these automotive engineers to understand what exactly is secure coding method and apply your skills and knowledge on these new cyberspace. There are so many solutions and innovative solutions being put as of now, and so many ventures in, especially in Israel, on auto security. And there are so many software developers as well. So software developers need to understand automakers' perspective, because that's where the problem is. So you're not just responsible for simply delivering the outcome or the output of that what's being asked from these managers, but also make sure that you do understand what their perspective is, what exactly they are lacking, inform them about it, and if it's a risk or a threat, do inform about that as well. So researchers, there's a requirement for collaboration from mechanical, civil, electrical, computer science, and cybersecurity, all across these different domains. So if you're any one of these, or you identify yourself as somebody who is interested in those two things, cars and cybersecurity, this is definitely your space. It's never too late to get into this, but it's super exciting to get into this as of now at this time. So current state of CAV technology, which is connected autonomous vehicle technology. As you can see, these are some of the locations or countries who are leading in this area, and states is already there. And hopefully, this is 2019's KPMG's report, and hopefully Canada is now there as well. So since Transport Canada is working on first pilot deployment, I know that there are so many of them in states, and there is very close by to me, which is M City in University of Michigan. This slide actually demonstrates it's not just those four types like auto engineers, software developer. It's also you if you're a part of government, industry, academia, or economic development. It's a whole ecosystem. If you identify yourself working in one of these domains, so this actually pictures from Canadian Ontarian entity who are driving this whole initiative. But this actually gives a whole overview that there is a participation from government, industry, academia, which is for research, and economic development, which allows the innovation to thrive. So if you identify yourself in each one of those, any one of those, that's very important because you have a role to play in it. So these are this is the example from here. I can just give you that in Ontario, there is a whole program and it has its own dedicated sites, and it works in a cluster-based view that it works, each region has industry and research for collaboration with the universities or colleges. And then they work, their work and its focus is very clear. So where I am placed, I'm in Windsor, so that's here. It's a southwestern Ontario region. So we focus here on cybersecurity of CAVs. Okay, so I wanted to inform you about, since I was mentioning about the education and training. So Automotive Security Research Group, which is ASRG, it's a non-profit initiative to promote the development of security solutions for automotive products. So what happens in the automotive industry with the OEMs, that it's a problem to share the information because it's a problem because of the IP. You're not able to share with the other OEMs what's going on. But if you identify a threat, for example, you do want to inform it, but you cannot inform it. And in security space, that's not the way you work or function. So you're supposed to share that information and have a threat intelligence platform. So ASRG comes up with that threat intelligence platform, and it's getting above from those different OEMs and creating a whole layer of it. And it works, it focuses on knowledge, networking, and collaboration. So education is one of the pillars which falls under the knowledge. And I'm actually working on building a whole network, academic network, where if universities and colleges, they want to participate and open their own ambassador program or their chapter in their institution, they can spawn that, and then we can have a global academic network, which will allow the researchers to work closely with the different universities and get more information and have collaborative way with the industry to work on these problems. These are some of the locations. So in North America, we definitely have good presence. I don't see chapter by you, but it's the Detroit one which is closest. So definitely we can have a Chicago chapter if somebody is already interested in it, that you can actually start your own location. And it has been growing really quickly and really fast based on the number of members as well and locations. I just wanted to inform you that, as I earlier mentioned, that I'm also with Devices, which is for women in cybersecurity. It's a sister kind of a way for CSNP, and we have here for Windsor, we have a student chapter too. So I founded that as well. Thank you so much. If you have any questions, you can ask me. And if you want to contact with me later on and discuss on something, this is information. I'm on LinkedIn. Most of the time I'm available there, but I'm also on Twitter. And this is my email address.
Thank you so much, Dr. Sani. That was a great talk. So Daryl has raised his hand and has something to ask or say. Daryl, you can come to the chat and drop your question there. Maybe
you can unmute yourself.
Yeah, I can. Okay, there we go. Hi, Daryl. You can talk now. I give you permission.
No, I'm sorry. I just made a mistake. I'm just really listening. I'm so sorry.
No problem. Okay, so we can go back to the way it was. That was an interesting concept. I did not realize how many different sectors are involved in this. Like, I totally didn't think about the government part of it and how computer science and automotive ties into it. And, you know, it was very interesting.
That's true. When I get involved, when I was very new, I still am learning. I'm still learning on the supply chain. And when I talk to OEMs, they have a completely different view of V2X or CAV technologies. So they see, because it's a legacy system they have vehicles already. So now it's a big challenge for them to actually change that whole model. The way they work and they function, they have to change it from operations and change for supply chain as well. So I never realized that there's a problem there for security.
Yeah, the only issue I've heard of so far is of a replay attack with the key fobs for cars. If you have, it was a possibility. I don't know if they solved the problem yet or they're still trying to solve it, but that was a big issue that I've heard of, that you can do a replay attack and get into a car.
Yeah, and the scariest part that I feel, that's just a key fob, and I'm just focusing on that as well. The scariest part there is that the radio that you will use for that, or the whatever device you're going to use for that, it's so cheap. You can find it on Amazon, and anybody can get that and play with it. And that's what the scariest part is. And when I talk about V2X, my whole dissertation was on passive attack, kind of sniffing the whole network. And just based on sniffing, how much analysis you can do on that information that you collect over time in a region. And you simply can know where's your home, where's your pattern, where you're moving, where you're going, without even actually sending out that information to somebody, because it's a broadcast. You're broadcasting that information in the network. So that's a big problem. And we need many minds to work on that.
How long do you think it'll take for all of us to come together and fix all of these issues?
You know what I'm doing as of now? I'm trying to educate as many people as I can and tell more and more people to get involved in it, because it's not just one side's problem. We need to see it from different ways. And I might be still missing different things that I might not be able to observe, but I think it will take a while as of now where we are.
Yeah, it's definitely a good start.
Yeah.
Spreading awareness definitely helps a lot.
Yeah. One of my friends is in the University of Michigan, and he is focusing on campus security. And somebody told him, a pioneer in this domain, he told him that get involved in this early on, because this is going to be very exciting domain to work. And we both do the same thing. We try to educate and aware everybody around us.
So Jeffrey has asked a question in the chat. Jeffrey says, in the past, there was not yet clear direction as to whether DSRC or cellular would be the network of choice. Some companies were pushing DSRC, some were pushing other solutions. You specifically mentioned DSRC in the talk. Is it now clear that DSRC will definitely be used? Example, have all major industry and government players agreed, or still a bit of debate?
So actually, I try to always stay away from this issue since it started heavily in November last year. Why I was inclined more to DSRC to answer that, since it's more proven and research topic. So since you are in academia, you're supposed to work on something with a heavy base and a foundational work done with it. With C2V2X, it's more industry driven, and there's an alliance there which is forming it, and there is no let's say, I shouldn't say no, but very less of the evidences that it's gonna thrive and work more, but because it's more inclined towards the 5G. So based on the usage, I think there's a still full-on debate going on with the usage of DSRC and Cellular. But I can see that partially the auto manufacturers who were inclined towards DSRC, they started getting CV2X as well. So we'll see what's going to happen there. But if you think in terms of, I actually, if I have to go with one of those, definitely DSRC, because when you go in the system itself and see the system design, you don't want any sort of radio interference with your safety information. And that's what the problem is with CV2X. It might hinder your, since it's a safety information that you are sending, you don't want to have it overlapped with all the other infotainment system information. So that's why I see it's critical to save a different bandwidth or a channel for the SRC and use it for safety related purposes. And if this answers your question, just let me know.
Thank you for your question, Jeffrey.
How do you see cybersecurity and virtual reality technology? That's a completely different answer, but what I say, it's very innovative as of now. And actually, it's how I would see it is we can learn a lot using virtual reality technology. And if we have that, we would be able to see things which, especially if I'm just thinking in smart mobility sphere, it would just aid with whatever we are having. It will just accelerate the processes and the operations and the way we deal with some of the things. It will be just more transparent and easier to handle. But that's not a concrete answer. I definitely know. If you have some insights, you can always share.
Yeah, virtual reality seems like a completely different world
Yeah.
at this point.
Yeah.
But
we need more people to educate that as well.
yeah.
I worked with few people who were working on a framework for ethics and virtual reality. That's very exciting as well.
You know, it makes me wonder if, from a smart car's perspective, if everything else around it is kind of augmented reality, where it has to read its surroundings, you know.
Oh, you now took me to different version. There is something I want to add, because there's a whole problem of testing with the autonomous vehicles. There's a digital twin. There are digital twins used for that. For example, we have here in Windsor, digital twin of the N-City and Ann Arbor. So by having that, what we are going to have, we can manipulate the information there or the scenarios, and then we can have the testing, a lot of testing there, and have data to analyze and work on it. But what happens with the data on the road? There are threats in the real life problems, right? When you're going there, you don't know if you encounter so many cases that has happened that the autonomous vehicle hit somebody. So we don't want to see that. So I think not the virtual reality, not completely augmented, but digital twin is something that's definitely is getting a lot of attention as of now. I forgot to mention that.
Makes sense, yeah. Yeah, if there are no more questions, I wouldn't want to hold anybody up anymore. Feel free to connect with Ikjot, like she said, on LinkedIn or any other way if you want them to communicate with you besides LinkedIn also. I just wanted to say thank you so much for such an informative talk. We're really happy to have you here, and this is definitely an area that I've never thought of before, and it was very enlightening. And thank you for everybody for joining us tonight and also having patience through our initial technical difficulties. We look forward to seeing you at the Command Control Hackathon. It's on Wednesday, November 11th. It's going to be from 5 o'clock to 8 o'clock. I will go ahead and share the registration link in the chat right now. Lastly, if you would like to be a part of our CSNP community, join our Slack channel, go ahead and follow our social media, check our website. You will find all of the information on our website to any way you want to reach us, really. You can also just contact us by emailing us at info@csnp.org, or reach the Chicago chapter directly by emailing us at chicago@csnp.org. That's all I have for you all. Thank you so much. You were a great audience. Thank you, Ikjot, for joining
Thank
us.
you so much for having me.
And have a nice night.
Have a nice night, everybody.
Bye.
Bye-bye.